this video, I will work through a couple of examples of compound interest problems. To start with, I need that formula. And the formula that our book gives us is here in the pink box. And this formula is going to be a formula that finds the future value, or the amount, the amount in the account after a certain number of compoundings in a certain period of time. After I have the formula, and what I recommend, by the way, is actually writing that formula on your paper each time you are using it. But since I have it printed here on my page, I'm not going to rewrite it because I'm writing on that page. But if you don't have this formula written on your page, start by writing that formula. And then I'm going to pull out all of the necessary information that's given in the problem. So we have how much would you need to deposit. That means I'm seeing that I need to find the how much to invest. Find the principal, or P. In order to have $2,000, so have $2,000, that means that the amount, or the future value of the account, is $2,000. In 8 years, so time is 8 years, assume that the account earns 8.54% interest, compounded weekly. Now, if something happens weekly, then the N, the number of times that occurs in a year, is going to be 52, because we have 52 weeks in a year. Just as a side note, some things that you need to know is that you need to know that there are 52 weeks in a year, and this isn't quite right, but it's what bankers use. There are 365 or 366 if it's a late leap year days in a year, right? We know that. But for financial purposes, we're going to use 360 days in a year. And that's computed by saying 12 times an average of 30. So I know there's not exactly 360 days in the year, but that's the number we'll use so that we're consistent with bankers across the world. Okay, so we've got our A is 2,000, time is 8, rate is 0.0854. So I could move this decimal 2 to the left, or in other words, divide by 100. N, the number of compoundings, is 52. So when I plug this information in, I'm going to replace the A with 2,000, solving for P, times the quantity of 1 plus 0.0854 divided by 52, all raised to the 52 times 8. And when we look at that, 52 times 8, what is that? That's telling us over the course of the loan, how many times is it compounded total? So 8 years, 52 times a year, 8 times 52. And that's going to give us 416 times that it's compounded. Next, I'm going to solve for P by dividing both sides by this complicated piece. And so this gives us the P. Now, putting it into the calculator can be a little tricky for some, depending on what calculator you're using. I'm using a pretty simple scientific calculator, the Texas Instruments 30X2S. It's a pretty common scientific calculator. And in this calculator, what I need to do is say 2,000 divided by, and now I'm going to put parentheses around this denominator because I want to get this piece added and then raise it to the exponent before I divide. So I'm going to say 2,000 divided by parenthesis 1 plus 0.0854 divided by 52, close the parenthesis, and then I'm raising just this part in the parenthesis, so I use a caret, to the 416. Now I got that 416 by doing 52 times 8. And when I put this in the calculator, I get approximately 10105629. Rounding it to the nearest cent would give us $1,010.56. And that is the answer we're looking for in this first question. Here's another example, one that I'm going to say is a little easier because we're compounding annually. So that means that if we've got 17 years, n is going to be 1 because it's 1 time a year. Notice, by the way, that the interest rate needs to match the time. So the 17 years and the 7%, when we're not told otherwise, that interest rate is an annual rate. But always watch out that if it's a daily rate or a quarterly or monthly rate, that your time is matching that. But we have an annual rate and a time in years, so we're okay. Again, I've got the formula written down, and I'm going to write out the given information. The amount is 5,000. Time is 17 years. The interest rate is 7%, so 0.07. The number of compoundings, or n, is going to be 1 because that happens once a year if it's compounded annually. And I'm going to solve for the principal, solve for p. I'm going to fill those numbers in. So 5,000 equals p times 1.07 raised to the 17th power. That's 1 plus 0.07 divided by 1. And in the calculator, this is a little simpler. It's just 5,000 divided by parenthesis 1.07 raised to the 17th power, close parenthesis. So that's what I'm saying when I do this is I'm going to divide by this piece that's raised to the exponent. And that gives us approximately 1,582 and 87 hundredths, or 87 cents. And that wraps up that problem. Now, some of these problems might seem easier than others, but if either of these videos leaves you with some remaining questions about this type of problem, please feel free to reach out. Or if you have questions about other problems in our content, then please let me know what you're struggling with, what ideas, what concepts you need a little bit more guidance with, and I'm happy to help you, because online doesn't mean that you're on your own. I'm here to support you. So thank you to the students who've sent this question in, or both of these questions in. And I hope that you found these videos helpful.